I'm going to continue the sustaining proliferative signaling what I've talked about last class. So the question is that how cancer cell actually sustain their proliferative signaling. To understand this, we have to understand at first the cell cycle and how it is controlled in normal cell and how it is deregulated in tumor cell or cancer cell. So the thing is that all cell cycle have actually basic 4 phases. First one is that M, then G1, S, G2. So when actually a cell divide after division, cell actually come to G1 phase. After coming to G1 phase, if the cell actually have certain kind of factors or extracellular signals, we can say the growth factors on the extracellular matrix of the cell, then the cell actually get the permission to move from the G1 to S phase. So the transition from G1 to S phase actually irreversible. When the cell comes from the G1 to S phase, there is a point is called restriction point, and when the cell actually moves from the G1 to S phase, this requires certain amount of growth factors on the extracellular space of that cell. So some cells in our body actually have they maintain a state is called G0 state. G0 state means that those cells actually don't divide during the lifetime, and this is called the irreversible quiescence phase for say brain cells, as you know. And also in G0 and also liver cells, they also stays on the G0 phase, on the G0 or quiescence phase for years. They divide rarely, and in liver also they maintain on the G0 state. But if they get some stimulatory factors like growth factors, and if they get some signaling like this, then they have the capability to pass from the G1 to S, then G2 followed by mitosis, and they divide again. And those cells actually are called differentiated. Those cells who are actually differentiated cells means that from the stem cells they have differentiated to the particular cell type, and after division actually they require some certain kind of growth factors which will actually regulate the division. In the context of wound healing, what happens actually, if there is a cut on the skin, then what happens? If there is a cut on the skin, clotting takes place to stop bleeding, and when actually clotting takes place, there is a process where platelets actually come and aggregate. After the aggregation, clot actually forms. During the time, simultaneously, platelet actually secretes some certain kind of growth factors, as I discussed last time, is called PDGF, platelet derived growth factor. These growth factors actually have the capability to induce cell division of the nearby tissues on that context to construct or to reconstruct the tissue architecture. So it's very important for a cell to have a certain level of a certain concentration of growth factors on the extracellular space to move from the G0 or G1 to S phase. So platelet derived growth factor actually is a mitogen. Mitogen in the sense, mitogen actually some protein or some factors have the capability to induce mitosis. So we can say the platelet derived growth factor actually is a potent mitogen, means these factors actually have the capability to induce division of the cell by means of proliferation. So next what I am going to discuss that how actually this mitogen or this kind of growth factors have the capability to induce cell division. First say some scientists have done actually some experiment by which we come to know that actually for the division of the cell, growth factors is required. If you take a petri dish and put some fibroblast cells then if you give them nutrient and all the requirement which are actually required to culture the cells in vitro, then what we will see that the cells will be alive, but they will not divide or they will not proliferate. Why they do so? The matter is that they actually require this kind of growth factors which will induce or which will tell them that this is the time actually they have to divide. Simultaneously, if we add serum on the petri dish, then interestingly the cells will start dividing. So it means that on the serum there are some certain kind of substances which actually are required for the division of the cell. How we will get serum? Actually, if we have to take blood and allow the blood to clot or coagulate. Then after coagulation, actually it will form a clot, and rest of it what we will get, and that is serum. If it is come from the bovine, we can say that it is bovine serum. Okay, so those kind of serums actually are used in cell culture to induce division or for the proliferation of the cell. Actually, those different kind of growth factors actually are required for the division of the cell. So, interestingly, if we look into the cell cycle, what we will see that PTGF actually, as a mitogen, have the capability to for the transition of the fibroblast cells from G1 to S phase. Actually, what happens? PTGF is a dimeric protein basically. PTGF actually is a dimeric protein. It is made up of two subunits which are analog of each other. This actually comes and bind with the receptor which is called the receptor of PTGF, which are present on the plasma membrane, extracellular side of the plasma membrane. So what happens that cell actually continuously assessing for the growth factor, for the presence of the growth factor. So cell can sense that how much growth factor is present on the extracellular surface of the plasma membrane, and accordingly they take the decision on a point is called resting point, where cell actually take the decision go versus no go. So the go versus no go decision actually is influenced or taken by the growth factors which are actually are secreted by the different cells, not by themselves, different cells of the tissues. And when on the restriction point or resting point the cell have not the adequate amount of growth factor, the cell again go to the Z0 phase, which actually is the quiescence phase in the brain cells also, and in the liver cells also. Also these cells which actually are in the G0, we can say those cells are post-mitotic cells. So there are some certain kind of signals which actually inhibit the cell cycle. Means there are certain kind of growth factors, some factors like transforming growth factor beta, TGF beta, transforming growth factor beta. This factor actually has the capability to stop the cell cycle. It means that this growth factor tells the cell that stop on the restriction point, and the cell again go to the G0 phase. If the cell actually experiences more and more TGF beta, then the cell have not the capability to transit from the G1. PTGF actually is a protein. It's basically a dimeric protein which is made up of two subunits. One subunit is equivalent to another, and this protein actually have the capability to bind with two receptors simultaneously at a time. And PTGF receptor actually it is present on the plasma membrane, as you are seeing here, and this actually has ectodomain, means extracellular domain, and transmembrane domain here, and the cytosolic or intercellular domain. So PTGF receptor actually is anchored on the plasma membrane. The transmembrane domain actually is made up of a stretch of amino acid, hydrophobic amino acid basically, and this hydrophobic amino acid is giving the power to the receptor to move freely on the plane of the plasma membrane. And this receptor dimerization is really important for the downstream signaling of the receptor. So when PDGF comes, it binds to a single receptor, and after it it increases the affinity for the binding of the another receptor, and simultaneously the another receptor comes and bind with the another subunit of the PDGF. What happens? Interestingly, when PDGF actually bind to the receptor, it pulls another receptor next to one another, and previously they are actually floating around the plasma membrane. It will cause the two different receptor molecule to dimerize. It actually will cause two receptor molecule to dimerize, and after it, what happens interestingly, that the subunit A actually modifies subunit B on the intercellular side of the cell, and subunit B modifies the subunit 1. A modification takes place by means of phosphorylation. Actually, subunit A phosphorylates subunit B, and subunit B also phosphorylate subunit 1. It's a kind of transphosphorylation. So phosphorylation takes place on the tyrosine amino acid residue of the protein. Different type of means the high energy gamma phosphate of ATP actually is transferred to the tyrosine residue, which is present on the intracellular domain of the receptor, and successively what happens, certain kind of protein molecules are present on the intercellular space of the cell, on the cytosolic phase of the cell, and it increases the affinity for those proteins to come and bind with them. So the lollipops are here shows the phosphate groups, high energy gamma phosphate of the ATP, and which actually are transferred on the tyrosine residue of the receptor molecule, and subunit A actually phosphorylate the subunit B, and subunit B phosphorylate subunit A. Basically, these are tyrosine kinases. Basically this portion is the intercellular subunit, intercellular part of the receptor have the intrinsic tyrosine kinase activity by which they actually transphosphorylate each other. And after phosphorylation, what happens? Certain kind of protein molecules come and bind with them. Certain kind of protein molecules actually come and bind with them, and they become activated. This phosphate group is transferred from here to the protein also. For say, it may be the protein kinases which actually are in inactivated state. After phosphorylation, they become activated, and after activation they actually may give rise. They may activate some different kind of metabolic pathway which actually are required for the division of the cell, or it may activate some certain kind of transcription factors which will go to the nucleus and bind with the gene which actually are required for the division of that cell. So what we are understanding, or what we are learning over here, that is that PDGF actually is a protein kind of molecule which is secreted by enucleated platelets, and the receptors actually are present on the fibroblast, and PDGF comes, bind with the receptor, dimerization takes place. After dimerization, transphosphorylation takes place because of the intrinsic tyrosine kinase activity of the receptor, and after it, what happens? The downstream signaling cascade activated, by which cell is actively taking part in different metabolic pathways, and cell is going to express some certain kind of genes which actually are important for the division of the cell. So this is the way by which cell have the capability to induce division or proliferation. Cancer cells actually somehow have deregulated the signaling pathway by which they actually have very little requirement of growth factor, or they have actually no requirement of growth factor, which actually are produced by different cells in normal physiology. What they have done, that is, cancer cells actually have the capability to induce or to express those genes which actually are responsible for the production of growth factors. Here what we are seeing, that this is a cancer cell and this has the capability to express the gene which is required for the production of epidermal growth factor, and they are producing the epidermal growth factor and secreting on the medium, and again this growth factors comes and bind with the receptors which is present also present on the cancer cells. But in normal cells what happens? In normal cell, those cells who are producing the certain type of growth factor does not have the receptor to respond. For instance, the cells which are present on the lining of our gut have the capability to produce platelet derived growth factor, but they have not the receptor. That platelet derived growth factor comes and bind with those cells. So the thing is that in biological system, what the matter is that those cells who actually have the capability to respond to the growth factor does not have the capability to produce the growth factor, and those cells which have the capability to produce growth factor does not have the receptor. So cancer cell actually they have the capability to deregulate the signaling pathway, and somehow they have acquired the capability by which they can express the growth factor and sustain the proliferative signaling. What happens, that EGF is secreted by the cancer cell itself, and this epidermal growth factor again binds to the receptor which is present on the plasma membrane of the cancer cell. So this is certain kind of signaling pathway, what we can say autocrine signaling pathway. Autocrine signaling pathway, cancer cell actually speaks with himself, and somehow the signaling pathway actually will deregulate and causing uncontrollable proliferation of the cell, which leading to development of cancer. This is the another way by which actually cancer cell sustain the proliferative signaling. What they do actually, they start to overexpress the growth factor receptors which basically are present on the plasma membrane of the cancer cell. In normal physiology or in normal situation, if you can say that there is 500 epidermal growth factor receptor or PDGF receptor, when a cell becomes cancerous, what happens, that they increases 10 to 20 or maybe 50 times more expression of the growth factors receptor. So what happens, that in normal situation, if you have 500 growth factor receptor on the plasma membrane of the cell, when the cell actually becomes cancerous, what happens, that they start to express the growth factor receptors in a very high concentration, in a very high rate. As a result, what happens, that these growth factor receptors actually are anchored on the plasma membrane, as we have discussed previously, that the short stretch of hydrophobic amino acids which are anchored on the plasma membrane, they actually make the receptors enable to move or traverse throughout the plane of the plasma membrane. And what happens, when the number of the receptors are increased on the plasma membrane, then actually they start to bump with each other. Then what happens, that when the signal is absent, means the platelet derived growth factor or the epidermal growth factors are absent on the extracellular matrix, on the absence of the signaling molecule, then also the receptor molecules come with each other and they actually start to emit the downstream signaling cascade. This is the main problem, or this is the actually identified problem by which some drugs come to market. I will discuss later about the eraser. It's actually a drug which actually worked on the non-small cell lung cancers. It's a type of lung carcinoma. Carcinoma is basically the cancer of epithelial tissue, what we have discussed previously. Whatever, that the thing is that when when a normal cell become cancerous, they start to express those receptors, those growth factor receptors aberrantly or in a high level. The expression of the genes of the growth factor receptor become more and more, 10 to 20 or 50 times more than the normal situation. And these receptors actually, due to their abundance on the plasma membrane, they actually randomly bump with each other and they start to emit the downstream signaling cascade on the absence of the growth factor. So these are the facts which regulate to the uncontrollable growth of the cancer cell. Here I would like to say a special case of glioblastoma. What happens here that in this type of cancer, actually basically glioblastoma is a cancer of nervous system. What happens that actually glial cells actually are some cells which nourishes the nervous system neurons. Basically these are present on the central nervous system of the brain actually, and glioblast actually are the stem cells from which glial cells are differentiated or formed. And what happens when actually glioblast divide, it requires some certain kind of growth factors. Here EGF stands for epidermal growth factor, and the epidermal growth factor receptor is also present here, as like we have discussed the PDGF receptor. And EGF actually come and bind with the receptors which actually is present on the surface of the glioblast cells and emits downstream signaling by which it divide normally. What happens in glioblastoma, in cancer situation, in cancer, what happens that the receptor of the EGF become truncated. Truncated means in the sense that the ectodomain means the extracellular domain of the EGF receptor, which is the N terminal, the protein being actually locked off, and as a result, when the EGF is absent on the tissue, on the extracellular matrix, those receptors actually are dimerized and become activated and emit downstream signaling molecules by which the cell start to divide and give rise to cancer. So what happens here that the cancer cell actually being eluded that the EGF is present on the medium and they start to divide. But what happens that EGF is actually absent on the surface of the cell. Basically, what happens when this kind of truncated receptor are formed? Why actually this kind of truncated receptors are formed? The answer is that the gene responsible for production of this kind of receptor, the gene which is actually responsible for the production of the receptor of EGF, there are some deletion or there are some genetic accident by means of chromosomal aberration by which the N terminal of the protein has been locked off, and as a result, what happens in the absence of the growth factor, this receptor dimerize and emits the downstream signaling cascade by activating some different kind of protein kinases as we have discussed earlier. Okay, next I'm going to discuss about ERASA. Basically, ERASA is a drug. Drug means low molecular weight drug. It's a molecule which have the capability to bind with tyrosine kinase receptors. Tyrosine kinase receptor means EGF receptor, epidermal growth factor receptor. In case of non-small cell lung carcinoma or lung cancer, non-small cell lung cancer is actually cancer which is associated with lung and it's basically a cancer of epithelial cells. What happens that in this cancer also the epidermal growth factor receptors are expressed aberrantly, and this leads to the development of a drug called ERASA. This it's a low molecular weight drug which come and bind with the ectodomain of the EGF receptor, as we have discussed already. The ectodomain here actually ERASA come and bind. Then what happened that after binding it actually blocks the binding of the EGF, epidermal growth factor. Basically it's also protein, and by binding on the ectodomain it inhibits the binding of the EGF, which normally takes place. But what happened that when people go for clinical trial, what they have seen that 90% patients has not responded, and 10% only, 10% patients they responded and cured. This leads to identify the cause. Why does this happens? The answer is that answer came after some couple of months by the research of some geneticists. What actually they find out that in non-small cell lung carcinoma patients, what happens that the ectodomain actually in 90% cases what happened that the ectodomain actually has been locked off in 90% cases. That's why it actually is unable to bind with the extracellular domain of the receptor. As a result, what happened that these receptors in 90% cases, in 90% patients, what happened that these receptors are actually activated by ligand independent manner. This is very important, that ligand independent manner they actually become activated and emits the downstream signaling pathways by which the cells actually are dividing uncontrollably. But it is a what does it comes and bind with the ectodomain of the EGF receptor. These EGF receptors does not have the ectodomain for which actually acts for the docking side of ERASA. That's why 90% patients has not responded. Though ERASA is toxic, it has different effect on the patients. That's why. But the thing is that 10% have actually been cured. What happened? Further genetic analysis revealed that in rest of the 10% patient, what happened? They have not the mutation on the ectodomain. They have the mutation on the different side of the receptor. That's why ERASA is actually able to bind on the ectodomain of the receptor and inhibit the EGF dependent signaling pathway, which leads to cancer. So the company which is producing the drug has been stopped because they can't produce drugs which actually act on 10% patients. So it's very important to understand genetic basis of the cancer cell by which we can produce or we can design rational medicine. What is rational medicine or personalized medicine? Personalized medicine is that when a patient comes to a doctor, the doctor can check the genetic makeup of the cancer cell of the particular patient, by which he can prescribe the medicine according to the genetic makeup. For say, PCR has been developed, as you know, polymerase chain reaction. By using PCR, when a patient comes to a doctor, he can quickly access to the genetic makeup of the patient's cancer cell, by which you can identify that whether there is mutation, whether the mutation is on the ectodomain of the EGF receptor or not. And after identifying that whether the mutation is on the ectodomain, if the mutation is on the ectodomain, then the doctor will not prescribe eraser to that patient. But if the mutation is absent on the ectodomain, then he can go for the prescription of the eraser. As a result, what happens, that eraser will completely remove the cancer, and you can reduce the drug mediated toxicity. So here is the importance of rational medicine or the personalized medicine, by which we can understand the genetic makeup of the cancer cell to identify particular drug molecules which will affect on the particular person's cancer differently. So what we have learned, that is, cancer cell actually employs some different kind of mechanisms, some different kind of mechanism to sustain their proliferative signaling, by which they proliferate, they divide uncontrollably and produce and give rise to the mass of tumor. Furthermore, this mass of cells actually inhibit the normal function of the organ, leading to death. Afterward, I will discuss about the metastasis procedure, by which actually a cancer cell gives rise to the different oncological lesion on the different organ. And metastasis is important to discuss because metastasis is the cause of 90% cancer related mortality.